Welcome back. We are going to talk about another important topic called the momentum, and it is closely related with the force and Newton's laws of motion. These are going to be our learning outcome. Now, what is momentum? Simply put, the product of mass and velocity. So we pick any particular object and you multiply its mass by the velocity, then you get what we call the momentum of that particle at that moment. So take this exercise. The momentum of a particle is 150 Newton seconds. What does this mean? All that it means is that if we multiply the mass and its velocity, we are going to get 150 Newton seconds. Simple. So momentum is simply the product of the mass and its velocity. So the greater the mass, the greater the momentum, and the greater the velocity, the greater the momentum. Now let's take this second example. We have a velocity time graph here, and it contains the journey of two particles, x and then y. You can see how the two particles were moving. The respective masses are also given: 10 kg for x and 3.6 kg for y. Now we are supposed to determine the momentum for x and the momentum for y at the time the two are traveling with the same velocity. So the first thing we need to do is to go to the graph and look for the time the two are traveling with the same velocity. At the beginning of the journey, particle x was at rest, about to start moving, while particle y was already moving with a velocity of 2 meters per second. Then we keep on going until we get to this point. That's 2.5 seconds. At that moment, particle x was traveling with a speed of 2.5 meters per second, and particle y was also traveling at a speed of 2.5 meters per second. So this is the point at which they are traveling with the same speed of 2.5 meters per second. So all that we do is to multiply 2.5 meters per second with 10 kg for x. That gives us the momentum for particle x at that time. Then we multiply the same velocity with particle y's mass, 3.6 kg, and what we get will be the momentum for particle y. Indeed, that momentum doesn't last at all. Shortly afterwards, it will change. The momentum of particle x will change, and the momentum of particle y will also change, because after half a second later, they'll be traveling with different velocities. So the momentum will change. That means the momentum is changing. The momentum is changing. At this time, the momentum is slower. At this moment, even though the masses remain the same, the velocities are changing. So the momentum for this particle, because they are accelerating, their momentum are changing. Now, why is momentum so important? Let's go back to Newton's second law and see something interesting. The law states that force is directly proportional to the acceleration. M is the constant of proportionality. So we have this simple equation: F is equal to ma. We also know that A is equal to the final velocity minus the initial velocity divided by the time taken. Let's substitute this one into the equation and we get this A, acceleration. Let's expand. If we expand, we have mv multiplied by mu. The interesting thing is that you realize that this is the momentum of the particle at some point, and this is the momentum of the particle at another point. Thus, the final velocity gives you a final momentum, and the initial velocity gives you initial momentum. So the numerator at this moment is final momentum minus initial momentum. We are talking about change in momentum. And this change took place within some time period. If we divide a change in momentum by the time period, we get a force. So, force can be defined formally with this expression. That means henceforth, if you are asked to define force, you no longer say it's the push or pull on an object. That one goes for the class 1 and the lower primary and the basic schools. But at this university college level, if we are talking about forces, then start thinking about the rate of change of momentum with time. That's momentum changes, and it does so within some time. If we divide the change in momentum by the time taken to change, that gives us the force. That means the forces that apply on bodies causes their momentum to change. Remember when we were talking about Newton's law, we talked about the force causing them to accelerate. If they are accelerating, they are invariably changing momentum. That's the key point you need to keep in mind. Let's take this example 3 to end our lesson. We have the same velocity time graph, and we are supposed to determine the forces acting on the particles using the definition change in momentum with time. Change in momentum with time. So we need to identify some final velocity multiplied by the mass and the initial velocity multiplied by the mass, and find the difference between them. Divide by the time interval. So here we are. Let's go for the x. The x, I will choose the initial velocity to be 0 to make things simpler, and the initial momentum will be 0, and the final momentum will be 5 meters per second. I'll multiply this one by 10 to give me the final momentum. So the difference between the momentum here and the momentum here will be 50 Newton seconds. Then I'll divide it by the time interval from here all the way to here. It is about 5. So if I divide it, I'm going to get 10 Newton. 50 Newton seconds divided by 5. That brings us back to 10 Newton. Alright. I could have chosen two different points on the same graph because the acceleration is the same throughout. For example, I could have chosen this speed as the final speed, that is 4, and chosen 1 as the initial speed. So the momentum at this point will be 10 Newton seconds, and the momentum at this point will be 40 Newton seconds. The time interval will be 1, 2, 3 seconds. So 40 minus 10 will give us 30 divided by 3 seconds gives us 10 Newton as the force acting on the x, the same as the first one we got using this long triangle. You could do the same thing for y, and I trust you can do it yourself. Thank you.